Okay, so in this video, we're talking about finding our way around the unit circle. And so if I have a unit circle like this, and I'm given an angle, I need to know where that is. So first we'll talk about in degrees, because most people are comfortable in degrees. So if and the 2 degrees that we're interested in, or the 2 kind of family of angles we're interested in, is multiples of 30 degrees and multiples of 45 degrees. So if you're given an angle like 210 degrees, you first ask yourself, is that a multiple of 30 or 45? And this is a multiple of 30, because 7 times 30 would be 210. So then we think up here at this angle, if you think about, since the whole angle, or the whole circle is 306 degrees, then if we divide that by 12, we will get 30 degrees. So that means that in each one of the quadrants, we have 3 partitions of 30 degrees. So it's helpful to be able to picture each one of these angle or terminal sides of the angle in each quadrant. So when I'm doing 210, it's good to orient yourself. You know that this is 180 because that's halfway around. This is 270. That of course is 90, and this is 0. This is 0 or 2 or 360. Sorry, 360. Change to a different color here. 360. Okay. So when I think 210, I want to know where 210 is. Well, 210 is a little bit past 180, so that would be 210 right there. Or if I'm asked to find 150 degrees. Well, 150 degrees is a little bit short of 180, so 150 would be 30 back from 180, so that would be right there, 150 degrees. Okay, and again, we're saying that this angle is 150 degrees. So the initial side of the angle is on the positive x-axis, and the terminal side of the angle is this blue line that I just drew. And likewise, if we were looking at multiples of 45, we could again divide the unit circle up. One full trip around is 360, so halfway would be 180, a quarter would be 90, so 45 would be right in the middle. And so again, in this case, each quadrant has 2 45-degree partitions in it. So if I have an angle like 225 degrees, well, that is a multiple of 45. We know that this is 180. And so 225 must be this guy right here, 225. So we're saying that this angle is 225 degrees. Keep in mind we can also go negative. For example, if I go negative 135 degrees, well, that means let me grab a different color here. I'll go with green again. That means that I'm starting on the positive x-axis, but instead of going the way I did last time, I'm going to go the opposite direction. And if I go this way, I end up at the same location, don't I? So I can spin a positive 225 and get to this location, or I can spin negative 135 degrees and get to the same location. These are what are called coterminal angles. Because they have their terminal sides are in the same place. So that's angle, that's dealing with angles in degrees measure, but we also want to be able to deal with them in a radian measure. So the similar idea, we have a unit circle. We know in radians that all the way around the circle, one trip around the circle is 2 pi, which means halfway around the circle would be pi. And of course this would be pi over 2, and that would be 3 pi over 2. And I want to in the multiples, so we also know that pi over 6 is the same thing as 30 degrees, and pi over 4 is the same thing as 45 degrees. So we're looking at those multiples. Now in this case, I think it's easier to tell because we just have to count. So if I draw in those same 30-degree partitions that I did before, this is CF colors, you notice. So pi over 6, that means each one of these is a pi over 6. So I can go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, etc. I'm just counting the pi over 6 as I go around. So if I'm looking for where is 7 pi over 6, well, I know that 6 pi over 6 is the same thing as pi. So that would be right here. So that means that 7 pi over 6 must be right here. 7 pi over 6. So again, I'm just counting when I have the unit circle drawn like I have drawn here, then if I'm dealing in pi over 6, I can just count my way around the circle. Notice that 5 pi over 3 is also a multiple of pi over 6 because 5 pi over 3 is the same thing as 10 pi over 6. So if I'm looking for 5 pi over 3, I can just count, or I can go to, for example, here, I know this is 6 pi over 6, so that would be 7, 8, 9, 10. So that angle would be 5 pi over 3. So I'd encourage you to play around with this a little bit and see if you can find your way around the circle. We need to get better at just knowing where you're at in the circle given the friendly angle measures, which are multiples of 45 and multiples of 30, or in radians, multiples of pi over 6 and pi over 4.